Well, thanks for watching my videos. I hope these are helpful. Hope I'm making this clear. We're going to do a couple more examples and we're going to talk about these concepts right here. What's the domain of a logarithmic function, and then how do you graph them? Okay, so look where the x is in this problem right here, right? So where is it sitting? Well, it's sitting where the number is located. And when I say the number, it is the number that you get after you raise e to some power. So we're going to raise e, the number 2.7 something, to some power, and we're going to get a number, right? So let's talk about I don't want to insult anybody's intelligence here, but like I just said, e is about 2.7, so e is a positive number. So look what we got going on here. We got a positive number raised to a power, and then it's going to equal something over here, right? So what we're really asking is, what could the number be? When it says what's the domain, we're really saying what could this number right here be, right? That's really what we're saying when we ask the domain question. We're really saying what could be sitting in this spot right here. What number, what number could be sitting right there? Could be there. Could be there. Okay? Well, I'm taking a positive number to an exponent, and it's going to equal something. Well, this has to be a positive over here, right? That's what has to happen. So the domain, this number right here has to be positive. Okay, well then ask yourself, x minus 1 has to be greater than 0, right? So if I move the 1 to the other side, x has to be greater than 1. It can't actually even be 0, because you can't raise a positive number to a power and get 0. There's no way you can make that happen. You can get close to 0, but you can't make it happen. So hope I'm making this clear. We're saying the number right here has to be a positive. That's the key. Okay. And you're probably going to answer the question in interval notation. So you're going to say 1 comma infinity, and then and that's it. That's all there is to the domain questions. All right. Whew, man, I hope I'm making that clear. Graph the following function and its inverse on the same set of the same Cartesian plane. Okay, so how do we do that? Well, an exponential function like 5 to the x looks like this, right? And its inverse is going to be the line that is, or the curve that's graphed over the line y equals x. So let me put down the line y equals x here in green. Oh geez, man, that's not very straight. Sorry about that. So y equals x is right here. That would mean that the inverse, like if we start plotting points over this line, right? So like there'd be one there, because like this point's going to go straight across the green line, right? And then this point's going to go straight across the green line. So we got those two corresponding points. This point's going to go straight across the green line, okay? And here's what it starts looking like. We get a function that looks like this. So this is our logarithmic function right here. This is the log base 5 of x if this over here, this red one, is 5 to the x. Now I wanted to show you how to use the little app. So I'm going to jump over to our assignment, and I'm going to pick one of those problems that we're talking about right here. And I believe it's going to be like I think it's number 19. So let's see if that's true, where they ask us to graph this. Dang it, that's not it. Okay, so let me go a little further. Here we go. This is number 20. All right, so how do we graph these guys? We click on this guy, and remember a 2 to the x function looks like this curve right here. So you just drop that guy anywhere you need to, and then you make sure that you adjust it accordingly. So the base is 2, it's not e, so we get rid of the e, we make it 2, and there's no vertical stretch, there's no horizontal translation, vertical translation, we have none of that stuff, shifts or anything. So I hit save. There's my exponential function, right? Now I'm going to put a logarithmic function on there. So logarithmic functions look like this. So you drop it anywhere you want, And then you need to change the base right over here, just like we did on the other one. The base on this one is, what was it again? It was 2, right? So see here's where the base is located. So I'm going to change that guy to a 2. And I guess you know what you can do actually is hit that little X button right there, on the other one, and it'll show you what the 2 graphs look like. Now, do they want us to graph y equals x on here? No, it just says graph those 2 functions. Remember how we were doing that before, how we had to graph the line y equals x? So they're not asking for that. That should do it right there. All right. So I hope I'm making that clear how to use the app for this stuff. Last set of problems look like this. Solve this equation right here. Okay, so it's again kind of like, how do you use the definition of what a logarithm is? This is our base, this is our exponent, and that's the number right there. The x is the number that we get after we raise 4 to the 3rd power. So 4 to the 3rd power, let's see, 4 squared is 16. 16 times 4 is 64, okay? So we end up with 64. If you want to just do that on Desmos, you can do that. I'll just say it one more time. 4 cubed, it's like this, and I was saying 16 out loud, like 16 right there, and then we have to multiply that by 4, and that's where we get the 64 from, okay? So, thanks for watching my videos. I hope the homework is a challenge, but not overwhelming, and call me over if you need some help. Thank you.